It's opening in Smart Notebook this time. Starting in 5, 4, 3. Hello, my name is Beth Dixon, and today we're going to be doing Math 1830 review chapters, and today we're doing section 0.7. So let's go. This will be simplifying some algebraic fractions, and this may be new to some of you. So let's look on how we're going to simplify some algebraic fractions. We're not going to get into a lot of detail here. There's a lot more that we could do with this. So we're going to keep it simple to those skills that you will absolutely need in this course. One of the things that you need to be able to do is to simplify when it is a division and we have monomials. And a monomial, remember, is where there's one term. Notice the top up here has no addition and subtraction. The bottom has no addition and subtraction. So that means it is a monomial. That means each of those are singular. So let's look at what we're going to do. The easiest way for me to explain this is, instead of looking at it in its totality, let's look at it in parts. So we're going to look at the numbers, then we're going to look at the x's, and then we're going to look at the y's and then the z's. My problem is 5x to the third y squared z divided by 20x squared y squared z squared. And so when we look at this, we're going to look at the 5 over 20, the x to the third over x squared, the y squared over y squared, and the z over z squared. So we're going to do each of those as separate problems, because if we do them separately, they're a little easier to handle. 5 over 20, 5 goes into 5 one time, 5 goes into 20 4 times, so that leaves me 1 over 4. If I look at the x's, I want to subtract. 3 from 2 leaves me 1, and it should be left on the top, so that should be x. And so that would be x to the first power, and it would be on the top. So to help me remember that, I'll just write it over 1. With my y squareds, 2 minus 2, they would divide each other out because they're actually the same number. And any number divided by itself would be 1. So that would just be times 1 over 1. And the z, one of those z's would cancel out one of these, so that one cancels and would leave 1z on the bottom, so that would be 1 over z. So we'd have 1z on the bottom, 2z's on the, 1z on the top, 2z's on the bottom, and one of those would cancel, leaving me 1 on the bottom. So now what do I have? I have x left on the top, and I have 4z left on the bottom, and that is a much simpler problem to simplify and to be able to work with. So I did it piece by piece and then put it back together. It made for a much simpler problem. Let's look at our next example. Our next example is x squared minus 9 over x squared plus 4x plus 3. In a previous video, we've looked at factoring. And so in this one, we should just factor both the top and the bottom. So on the top, x squared minus 9, because it has two terms, I know that this middle term will add to 0. So that means it's going to be the difference of two squares. I'm going to get an x minus 3, then an x plus 3. It has to multiply. These have to multiply to give me 9, and then the middle terms have to be opposite, so it's a minus and a plus, so that that middle term is 0. Now on the bottom, and I'm going to use a different color for the bottom here, on the bottom, what would I have? I would have two parentheses. I don't know why it defaults to that. I like the thinner lines there, so there we go. And then on the bottom, then what would I have? I would have x squared plus 4x plus 3. The leading coefficient is x, so I can write that as x and x. The last term is 3. Things that multiply to be 3 are 1 and 3. So that has to be a 1. That has to be a 3. The last term is positive, so both signs are the same as the middle. So that means you get a plus and a plus. If that's the case, then that should work. I can multiply that out again to check, and to check that would be 1x plus 3x, which does give me the 4x as the middle term. X times x gives me x squared. 1 times 3 does give me 3, so I'm good. We're going to then erase all my check there so it's not in our way. So we have factored this. Once we've factored this, we then want to cancel. And we cancel, and canceling is a non-mathematical term for dividing to be 1 in this case. So what's a number divided by itself? Where do we see a number divided by itself? We see a number divided by itself with x plus 3. X minus 3 is a number, x plus 3 is a number, they're multiplied. X plus 1 is a number, x plus 3 is a number, they're multiplied. So where do we see a number that's the same divided by itself? Well, x plus 3 and x plus 3 would be the same number, so we can take it into itself and it will leave us 1. So that leaves us an answer of an x minus 3 over an x plus 1. And we want to be able to factor and reduce our fraction from the x squared minus 9 over x squared plus 4x plus 3 into x minus 3 over x plus 1, because that will make it easier for us to look at and do our calculus on this problem. And so we have to be able to do that. So this one is a very important problem. Okay. Excuse me. And let's look at the next example, which is 2x over 4x minus 6. This one also can be reduced, but we do not want to take and divide the 2x into the 4x. This on the bottom is joined by that subtraction sign. Therefore, it can only be divided if it's a group. You cannot divide out an x that's been joined by an minus or a plus. I tell students there's no divorce in math, and we can't take that 4x minus the 6. Other people say, well, there is divorce, so that doesn't really work. So you can think of it as a children. You'll always be a parent. Yeah, we can get into other things that make that doesn't work. But what you want to remember is those two are joined together, and what math has joined together, nobody can take apart. So that 4x is joined to that 6. Before we can divide, before we can do anything, that division bar has grouped them together to the point that they have to be a group. So we can't divide this 2x and this 4x and get an answer. That does not work. So what we have to do is we have to factor. And the bottom can be factored because it has a greatest common factor. So we leave the 2x as is, factor out the common factor in the bottom, which would be a 2. 2 is common to both the 4x and the 6. So what's common is the 2. 2 goes into 4 2 times and leaves us 2x, and then the minus 6 gives me a minus 3 because 2 goes into 3. 2 times 2x gives me back the 4x. 2 times 3 would give me back 6. So now they share some multiplication. That is 2 times x, and then it is 2 times 2x minus 3. Things that are multiplied can be divided out. That is allowed. The 2x minus 3 is still joined together. The 2 has been factored out. If you factor it out, you can then divide it out, but it has to be factored out first so that it's a multiplication, because then we can write it as 2 over 2 times x over x minus 3. And if I multiplied that back out, I would get the original problem, because 2 times x would give me 2x, and 2 times x minus 3 would eventually give me 4x minus 6. We don't need to show this step. This is our thought. In other words, you can just think this step. You do not need to write it, but that's how the 2's divide out. The 2 divided by 2, any number divided by itself is 1. So our answer then is the x over x minus 3. Next question, we're going to multiply. So we're going to multiply x squared minus 4 over 6x to the third times 6x squared plus 2x to the third all over x squared plus x minus 6. The first step in this is to put it in factored form. To be able to reduce, we have to be able to factor. It cannot reduce. I cannot come over here and divide the 6x to the third and the 6x squared, because the 6x squared is joined. So I need to factor this. I need to factor the x squared minus 4. I need to factor the x squared plus x minus 6. So let's start with the x squared minus 4. The x squared minus 4 has no middle term, so that makes that the difference of 2 squares, because x times x would give me x squared. What multiplied by itself will give you 4 would be 2. And then I want to make sure one's a subtract and one's an add. The 6x to the third does not need to be factored because it's already multiplied. That is 6 times x to the third. Now going over to the second fraction, what do I have? Well, on the top, I have 6x squared plus 2x to the third, and that is only 2 terms. But it's not a trinomial. It's not the difference of 2 squares because it's not a difference, and they're not squareds. The first thing you always look for is the greatest common factor. So when you take out the greatest common factor, which would be a 2 and an x squared. Remember, you want to look at the numbers first. You have 6 and 2. 2 goes into itself and 2 divides into 6. So that would be your largest common factor, your greatest common factor. Then looking at x squared and x to the third, you look at the x squared, it being the smallest, and it does divide into x to the third without leaving negative exponents. So that is your common factor. So 2x squared goes into 6x squared and leaves me 3. Because if you multiply back 2x squared times 3, you will get 6x squared. Then plus, because we're not changing the signs, 2 goes into 2 one time, and x squared, so you can think of it 2x to the third, and I'm kind of dividing it by 2x squared, and that just leaves me a single x. Now, that works also because 2x squared times x, 2x squared times x gives me back the 2x to the third. And so either way that you want to think of it, either as division or multiplication, that's how you factor that out. And that gives us this answer for the top, which is 2x squared times 3 plus x. On the bottom, we have x squared plus x minus 6. Since the leading coefficient is 1, I can draw my 2 parentheses, then draw write in my 2 x's. My last term is negative, so I'll have one sign of each, and my number is 6. So 6 is 1 and 6 and 2 and 3, and I want to subtract to get 1, so that will be 2 and 3. So if I put a 2 and a 3, I then need to check my answer. And so let me check my answer down here. Of course, it's going to give me x squared. And then it's going to give me minus 3x plus 2x minus 6. And that would give me a negative 1x in the center, but that doesn't match up that positive x I have. Therefore, my signs are backwards, and I just need to flip my signs. So I need to make this here a minus, and the second one a plus. So I need to get x minus 2, x plus 3. Now that took a lot of work. That's the hard part. The hard part comes in the beginning. At the end, then we get, and we're able to factor and multiply rather quickly. Now, we're looking for things that can divide. And it's divide, as long as one's in the top and one's in the bottom, it doesn't matter whether they're on the same fraction or whether they're on different fractions. But one has to be in the top and one has to be in the bottom, because the fraction bar makes the division. If they're both on top, that's multiplied. If they're both on bottom, that's multiplied. To divide and to divide out, they have to be top and bottom. So as I look at the x minus 2. Is there another x minus 2? Is there another term that is x minus 2? And certainly there is. So there's an x minus 2 and an x minus 2. So that number divided by itself will give us 1. Then there's an x plus 2. I don't see another x plus 2. Then I'm going to go over to the 2x squared. Well, that 2 is multiplied independently, so I'm going to do that 2 into itself and get 1, and 2 divided into 6 and get 3. Then I'm going to do the x squared. 2 of these x's divide out 2 of the 3 here and leave 1. If you wanted to or needed to, you could write out, well, that's 2 x's, that's 3 x's, and these 2 cancel out these 2 and leave that 1. But basically, you're subtracting your exponent, and the x remains where the larger positive exponent is. Okay, next let's look at the next term, which is 3 plus x. Well, I don't have a 3 plus x, but I have an x plus 3. And those are technically the same thing because x plus 3 could be written as, 3 plus x can be written as x plus 3. It does not change the sign. Therefore, that can cancel out that, and that is gone. Each of those divides out and gives me 1. So what do I have left? Well, I have an x plus 2. And so I have an x plus 2. I don't have anything else left on the top. Everything else is marked out. What do I have left on the bottom? I have a 3 and an x times 1 times 1. This up top is an x plus 2 times 1 times 1 times 1, so it's just an x plus 2. So my answer then is x plus 2 over 3x. And I do tend to keep my x plus 2 in parentheses, so it reminds me that that x is joined to the 2 and cannot cancel with what's on the bottom because it's joined to the 2. I've added 2 to it, so it is no longer a multiple of whatever the number for x is. Okay, that's the last example, and that gives you the practice from your textbook, which would be page 43, 1 through 6, 9 through 11. If you need any additional help, remember that you can always contact me in the math lab. And to reach me, you can reach me at beth.dixon@ws.edu, and I am located on the main campus in Morristown in MBSS room 222, and would be glad to work with you. Remember that your instructor, whether this is Miss Moneyhun or one of the other instructors for this course, is also a source of information, so contact your instructor as well. Thank you for watching. End.